Hello everyone. Today our main focus is to see how to use split command to create multibody parts, multibody file. After that, let's see how we can use that multibody file to create an assembly. There are some benefit of using multibody technique, using multibody part file to generate an assembly. One, you can improve the productivity by designing assembly inside a part file. Number two, it is very easy to control the design from one location just by changing one part file. Number three, we can quickly update the assembly directly via part file editing. I will demonstrate this concept by designing this hinge. Let's get started. Open up a new part file and go to home position. Click on start 2D sketch and let's create a sketch on XY plane. I will follow these dimensions, the first row of the table. AB, C, D, E, F, A50, B50, C34, D, E, and F, M4 countersunk hole. Click on rectangle tool, draw rectangle like this. Let's add dimensions, 50, thickness 2, and let's add coincident dimension, coincident relations between midplane and origin. The sketch is fully defined. Click on circle and look, just by looking at this, the position of the circle seems to be on the top line, and click on this point and create a circle 7mm diameter. Those dimensions, some of the dimensions are assumed by me just based on the other dimensions. Make this one 7mm and the distance between these two circles 2mm. So the inner circle would become 3mm. I will make this one 1.95, slightly bigger than 3mm, because I'm going to use 3mm diameter pin. Though the outer diameter of the two end of the pin is 4, the inside is 3mm. So let's extrude this sketch. You don't have to finish the sketch, just go to 3D model, click on extrude. Now let's select these profiles. You can shift and middle mouse button to rotate. Click on all these closed profiles except the center one. And for the distance, which is A, let's add 50, and I will make under direction symmetric. Click on OK. Alright, now the base part is completed, and let's use split command to split this into two pieces, left flap and right flap. Click on this surface, add a new sketch. Just create a sketch similar to the shape of the cutout. And make these two line equal and collinear constraint and coincident constraint between this point and this point. And let's add dimensions. Make this point to point 0.25mm and make this point to point 0.5mm. Later you will realize why I have done that. And add the center dimensions 30mm. Based on this sketch, I have assumed that this is 30. We can make it 25 as well. And now the one sketch is created, and let's use offset command. Select this sketch, make it offset by 0.25 millimeter. So now we have two parallel lines, and exit the sketch. And now we are going to use split command under modify to split this into two separate bodies. You can see here there is only one body. This is a part file, not an assembly file. I'm going to make it two separate bodies. In order to do that, click on split command under modify, under tool. When you click on that box, you can see there is a light blue line underneath. That means it is selected, it is active. Let's select one of these lines, and under the faces, we are not going to split a face, we are going to split this whole body. So you have to change these faces to body. In order to do that body, you have to click on this one. Now the body is turned on, and the body is already selected because there is only one body in this part file. So under behavior, keep side, there are three options. You can keep either side of the split bodies, or you can keep the both. I'm selecting both and click OK. Now if you go back to the solid body, you can see there are two solid bodies, 1 and 2. If you carefully look at this hinge, there is a gap clearness between these two flaps. So that's why I have created two lines. So let's create split command again to split this body, this side body, and this part. In order to do that, let's use this sketch, right click, make it share sketch, because we are going to use the same sketch. I'm not sure if we can select this sketch without sharing. You can try it by yourself. Now when you click on sketch sharing, share sketch, it will create a copy of that sketch outside the split command. That means this sketch is belong to the split command, as well as we can use it with some other command as well. Let's use split command again, and under select tool, I'm going to use the other line. First activate the command, tool side, and click on this line. Now the solid body is selected by default because that sketch is lying on this side of the solid body. So we can keep the both, click OK. Now if you look at the tree, you can see there are three solid bodies. We really don't need to use this solid body, so we can click on that one, right click, you can uncheck its visibility. Now we have clear two flaps similar to the hinge. And again you can see this area should be removed, because when the cylindrical barrel is in the middle, it is pure cylindrical shape, there is no any protrusion like this. So in order to do that, click on the surface, click on new sketch. In this case I'm going to make it really quick. In order to do that, we use project geometry command under sketch. So click on project geometry and click on the surface. What this project geometry command does is it projects all the line onto that surface, onto that sketch plane. Now let's click on the circle and create another circle at the center and stop it somewhere here. Make both circle equal. Now what I'm gonna do is I'm going to use extrude cut command to cut this profile. So in order to do that, select the profile, activate the profile by clicking on it and make this blue line appear, and then you can select this profile. Under the boolean output, we have to make it a cut, and under directions it is correct, and under distance you have to select these two. When you select this up to, you can select this surface. So that's mean this extrude cut stop at here. Click OK. Now let's use mirror command to use the same command on the opposite side as well. So click on mirror. Under the feature, click on this extrude command, and under mirror plane you have to select the mid plane, which is XY plane. Now you have to click on solid body. If you click on OK, I will show you. This is already selected, and make sure that you always select this side of the solid body in order to activate that command. Here you can see the two lines, two sides are fully cut. So we have another protrusion to cut on this end. In order to do that, click on this surface and click on new sketch, and let's use slice graphic command, and again let's use project geometry. And now again I'm going to project this surface onto the sketch plane. So you can select that surface, or you can select this side. You can select this surface. It is the same surface, same profile. Now click on the circle and again draw a circle similar to you did before, and now use equal command and make these two lines equal. So now you have again the closed profile here. You can cut this part up to this place. So go to 3D model, use extrude, and under profile select this profile. Under boolean make it cut, distance make it up to, and select this surface. Now that part is also cut. Now you can actually hide the sketch. Right click on the sketch and uncheck the visibility. There you go. Now you can see there are two clear hinge flap already generated. Now the last one, which is the pin. Let's use revolve command to create the pin, and also make sure to make it as a separate body. So in order to do that, click on either YZ plane, or you can click on XZ plane as well. Click on YZ plane and make it a new sketch, and go to slice graphic again, and let's create a sketch to the shape of the pin. You can draw a circle, a rectangle, and make it 1.5 in diameter, because the diameter of the pin is 3 mm. I'm going to use revolve command, and on either side we need to create a reverted shape. So in order to do that, make two rectangle at both ends and make both of them are equal. Use equal constraint. And now let's add few dimensions. Make this 0.5 mm, make it actually 1 mm, and this side also 1 mm, and make this one 0.5 mm, so that the outer diameter of the rivet become 4 mm according to these dimensions. The D is 4 mm. Now let's add few constraints. If you drag this one up and down, you can see there are no any constraint to this part. So what you have to do is, you can simply add collinear constraint between this line and this line. So this is a projected line from previous command. If it is not projected, what you simply have to do is use projected geometry command, just project one line, and then you can add constraint between that line and this line. So look like it is still we need 2 dimensions. If you drag it somewhere, you can see this side also not constrained properly. Then use collinear constraint and click on this line. So there is no any projected line, but there is here one projected line. You can make it a constraint. Now still we need one more dimensions. So if you drag it this way, you can see it is not constrained. So in order to do that, click on this coincident constraint and click on the midpoint of the line, and then click on the origin of the part file. Now you can see the sketch is fully blacked. That means it is fully constrained. You can see it from here as well. Then go to 3D model, click on revolve command, and under profile you have to select all these 3 profiles. We are going to revolve all these 3 profiles. We are going to revolve this one under axis. Click on axis, activate it, make it underline blue line appear, and then click on this line. Now you can see the pin is created, and now it is the most vital step. You have to make sure that this is going to be a solid box, separate solid body. So in order to do that, for the output you have to click on solid body. You have to click on this command, which is solid, create new solid. So when you click on this command, it creates a new solid body without merging it to the other parts. This is Inventor 2022, but based on your version, this dialog box would be different, but the commands are very similar. Commands are the same. So click OK. Now you can see the pin is created and the 4th solid body is also created. Now let's add some fillet. I'm going to click on this fillet command, and I'm going to make 0.5 millimeter fillet on this side. I'll make it 1 millimeter. Shift middle mouse button and 1 millimeter, and make all these 4 corners 1 millimeter as well. It is not added in here, but it's good to have that fillet at 4 corners. And let's add one more size. So in order to do that, click on this add button. So then we can add separate diameter. So I will make it 0.5 millimeter, and let's add 0.5 millimeter fillet on these edges like this, and hit OK. Now you can see almost the part is created. And remember, this is not an assembly file, this is a part file. I'm going to save this one. I'm going to save this one as a Hinge solid body file, and click save. And I will add material. I will make it stainless steel, and go to home button, home position, and click save. Now it's the last step. Let's add these 4 countersunk holes. In order to do that, click on this surface and add sketch, and use point, create 4 point at 4 corners. Let's add few constraint, horizontal constraint between these 2, and horizontal constraint between these 2, and vertical constraint between these 2 and these 2 as well. Now let's add some symmetric constraint. Click on this symmetric constraint command and click on this point and this point. Let's make it symmetric between x-axis click on x-axis, become symmetric between x-axis, and also click on vertical axis, z-axis, and oops, you have to reactivate the command again. Click on this symmetric and click on this point and this point, click on z-axis. Now it is symmetric under about x-axis and z-axis. Let's add finally the dimensions. Dimension between these two is E, which is 34, and dimension between horizontal dimension is C, which is again 34. Now this sketch is fully deconstrained. Go to 3D model, click on hole command. Now let's, under the hole type, select countersunk, and the diameter, make it 4.1, and for the top cap diameter, make it 7. If you look at the if you search in the Google, the exact size is 8 mm, but here it is more proportionate if you use 7 mm. I have tried this one before. And under termination, you can make it true all, and now you can click OK. There you go, and you can see the hole is created only one side. I will show you why, which is because if you go click, you can go edit, you have selected only one body. You have to select this body as well. In order to do that, you can select, you have to select all of them, input geometry, under input geometry, under solid, you have to click on this one as well. So there are two solids are selected, and click OK. Now you can see Hinge assembly is created with every single part, but remember, it is not an assembly. It is a pure solid file with separate multibodies. So what we are going to do now is we are going to use this multibody part file to create an assembly. In order to do that, first right click on these three solid bodies and let's label them, which is easy for us. So on this one, right click and rename. If you can't find rename, just click on this one, slow double click on that one, then make it left flap, and click on the right other one, slow double click and make it right flap, and third one, make it pin, and all three parts are solid body parts are labeled. Now let's make this one an assembly. So in order to do that, go to manage, and under here you have two options under layout: make a part, make a component. If you want to create an assembly easily and quickly, just use make component, not make part. Make part is for different purpose. If you click on this one, it will create a part file including all these parts, which will not be an assembly. It will be an assembly, but the selection would be one single part. If you use this option, it will create an assembly with individual separate parts. So click on this one, and under selection you have to click on these all three of them, and under target assembly name, let's create new one, assembly file, new Hinge RS Pro, which is RS Pro. I found this one from RS Pro website, RS component website, and make it 50 by 50. And assembly location, click on this one. When you actually click on this one, it is asking if you want to add this one to a new existing assembly file or you want to make it a new file. So if you want to select no to select an existing target assembly, and I'm going to click on yes to make a new target assembly. Click yes, and this is the name of I'm going to type the file name, it is the same actually, Hinge RS Pro 50 by 50 and click save, and now click on next, and here you can see all the details. You can see 3 selected body, you can see the component name reflected from selected body name, left flap, right flap, pin, template standard, bomb structure normal, file location, source path. So that's means all the files will be saved in the same location of the solid body part file. Scale factor 0, no mirror, and you can use this one, use color override from source component, it will override a color from source component, and we don't use parameters here, and click on apply and click on cancel. Now hit save again. If you go back to the tab, you can see there is new tab is created. When you click on that one, you can see new assembly file is created, which is an assembly file, not a part file anymore, which is an assembly. The name we just gave, with the name we just gave, and 3 assembly files are created. So this is how we can use multi-body technique to create an assembly. So in here actually you can make it more better by changing the home position, make it fixed to view, and now let's remember this, all when we create part files, assembly files using this method, all the files are grounded. There is no any relation between any of the relationship between any of the parts which are grounded, but the same as per the solid body part file. So what I'm going to do now is click on this one, right click and uncheck grounded. After you uncheck it, you can just drag it here and there. I'm going to add some constraint. Click on constraint, make it same as coaxial, and also click on this. You can use this constraint, align, oops, cancel, constraint is between this one and apply. After that click on flush, use this command and make these two flush and click apply. Now you can see if you go to home position and these two can't be dragged, but you can see still flap this one. So if you use this one in an assembly, you can make it assembly flexible, you can make the assembly flexible and play around with the whole assembly with a hinge. I hope this is useful, and by now you have a clear understanding about multi-body technique, clear understanding about how to build a multi-body part file, clear understanding about how to use multi-body part file to create an assembly. If you like this video, please hit like, and if you find my videos are useful, please hit the subscribe button, and I will see you very soon with a similar useful video. Until then, bye everyone.